In this video, we're going to solve equations that now have a logarithmic expression. It has exactly one logarithmic expression. So in the last video, we had an exponential expression, one exponential expression, one exponential expression. And we didn't have to check for extraneous solutions because if you look at an exponential, the domain of the exponential is all real numbers. You can put any number you want in, as long as it's a real number, into the exponent. So you didn't find me going back and checking my answers on any of these problems. However, on these you will, because when you have an argument, remember that the argument has to be greater than 0. So I'm just going to do a quick check. The argument has to be greater than 0 for each one of these. So on the first one, the argument is x plus 3. So I'm going to just say x plus 3 has to be greater than 0. That means x has to be greater than -3. And this is a quick and easy check that you can do when you have one logarithmic expression. I'm going to isolate that logarithmic expression by subtracting 4 from both sides. And the logarithmic expression that I want to get all by itself is just the log base 3 of x plus 3. So eventually, which is the next step, I'm going to need to divide both sides by 2. So I divide both sides by 2, and now that the log expression is all by itself with a coefficient of 1, I can put this into exponential form. 3 cubed is 27, and that's going to equal the argument, and therefore x will equal 24. 24 is most definitely greater than -3, so x equals 24 is our solution. Okay, let's try the next one. The next one, we're going to subtract 2 from both sides, giving us log base 5 of 2x minus 1 is equal to 2. 5 squared is 25, and that's going to equal 2x minus 1. I add 1, I divide by 2, and then if I did not come over here and take that argument as greater than 0 and solve, I can always at the very end check to make sure that my answer is not extraneous by putting the 13 back in. 2 times 13 is 26. 26 minus 1 is 25, which is greater than 0, so it does not cause a problem in the argument. X equals 13 is our solution. Okay, next problem, if you want to give that a try, remember we're looking for our answers in exact form, so calculators are to be avoided. They are not, whenever it says exact form, you never pick up your calculator. So if you want to give this one a try, that'll kind of test your algebraic abilities and build up that confidence. If you're not sure with this all divided by 5, how to get out of that, don't press pause, watch the first step, and then I encourage you to press pause and then check your answer at the end. Okay, here what I would do is, because I'm taking that entire logarithmic expression and I'm dividing by 5, I'm going to undo the divide by 5 by multiplying by 5. So I multiply both sides by 5, and that gives us the natural log of 2 minus x equals 5. Now, 2 minus x at the very end needs to be greater than 0. So that means negative x needs to be greater than -2. Because when you divide both sides by a negative, you need to flip the inequality symbol. So if I get a negative value for x, that would actually be a good thing, because a negative value is less than 2. Okay, so here we are. We've got base e to the 5th power, which is, if I take out my calculator, I'm going to get a number that's in the hundreds. I don't know if it's in 100. It's probably close to, it's more like in the high 200s, I would say. You can try it. E to the 5th power is going to be a number that's somewhere between 32 and 343. Sorry, 243. So maybe not the, no, 2 to the 5th, 3 to the 5th, 353. So it's going to be in the upper 200s. E to the 5th equals 2 minus x. Then I'm going to subtract 2 from both sides. So I've got this number that's in the hundreds, minus 2 equals negative x. I'm going to multiply everything by a -1, which is going to make my e to the 5th negative, and my negative 2 positive. So now I have this negative 100 value plus 2, which is a negative number. This negative number is going to be perfectly fine. It is not going to cause a problem whatsoever. Therefore, no extraneous solutions. Now, if you have extraneous solutions, if a value doesn't work, I'm just going to write this. If a solution is extraneous and it's the only solution, then the answer would be no solution. Then you would not have a solution. Okay, in the next video, we're going to talk about equations with multiple logarithms, and we're going to practice with a couple of problems and get you comfortable working with those.